Have you ever wondered what truly happens to a body after death? Beyond the initial stillness, a profound and often misunderstood process begins. The body becomes stiff. This phenomena, known as rigor mortis, is not just a macabre details from crime shows. It is a complex biological event that reveals the intricate working of life, even in its absence. Today, we will uncover the shocking truth behind why bodies become stiff, exploring the science, the timeline, and its crucial role in forensic investigations. So, what exactly is rigor mortis? In simple terms, it's the temporary rigidity of the muscles that occur after death. It's one of the most recognizable signs of death, alongside algor mortis, which is known as cooling of the body, and livor mortis, which is discoloration. But to truly understand it, we need to delve into the microscopic world of the muscle cells. Our muscles contract and relax through a delicate dance between two proteins, actin and myosin. This process requires energy supplied by a molecule called adenosine triphosphate or ATP. When a muscle contracts, myosin heads bind to the actin filaments, pulling them closer. For the muscle to relax, new ATP must bind to the myosin heads, which allow them to detach from the actin. This continuous cycle of attachment and detachment is what enables movement. However, at the moment of death, the body's ability to produce ATP ceases. Oxygen is no longer delivered to cells, and metabolic pathways that generate ATP shut down. The existing ATP stores are quickly depleted as the muscle continues to function for a short period, even after heart stops. Without fresh ATP, the myosin heads remain locked onto the actin filaments. They cannot detach and the muscles become fixed in a contracted state. This is the essence of rigor mortis, a permanent muscle contraction due to the absence of ATP. The timeline of rigor mortis is generally predictable, making it a valuable tool in forensics. It typically begins about 2 to 6 hours after death, starting in smaller muscles like face, jaw, and fingers. This is because smaller muscles have fewer ATP reserves and deplete them faster. Over the next 6 to 12 hours, rigor mortis spread throughout the body, affecting larger muscles groups in the limbs. It usually reaches its maximum stiffness or peak around 12 to 24 hours after death. At this point, the entire body is rigid. But rigor mortis does not last forever. After peaking, it gradually begins to subside, a process known as resolution. This usually starts around 24 to 36 hours after death and can take up to 48 to 60 hours to completely disappear. The resolution occurs due to the breakdown of the muscle proteins by enzymes released from the lysozymes within the muscle cells. These enzymes, no longer contained by the living cell membranes, begin to digest the locked actin and myosin filaments, allowing them to relax once more. This process is essentially the beginning of the decomposition. Several factors can influence the onset, duration, and intensity of the rigor mortis. Environmental temperature is a major one. Warmer temperatures accelerate the chemical reactions, causing rigor mortis to set in and resolve faster. Conversely, cooler temperature slow down these processes. A body in a hot environment might show full rigor within a few hours, while a body in a cold environment could take much longer. The individual's physical activity before death also plays a role. If a person was engaged in a strenuous exercise or struggling intensity just before dying, their muscle would have rapidly depleted ATP stores. This can lead to a faster and more intense onset of rigor mortis. Age and muscle mass are also factors. Children and elderly or individuals with less muscle mass tend to develop less pronounced rigor mortis and it may be resolved more quickly. While rigor mortis is a key indicator, it is not the only postmortem change. Rigor mortis, the cooling of the body to the ambient temperature, begins immediately after death. Rigor mortis is purplish red discoloration that appears on parts of the body closest to the ground due to blood settling under gravity. These changes, along with eventual process of decomposition, provide a comprehensive picture of the post-mortem interval. For forensic scientists, understanding rigor mortis is crucial for estimating the time of death. By examining the extent and distribution of the stiffness along with other post-mortem indicators, investigators can narrow down the window of when death occurred. This information is vital in criminal investigations, helping to establish timeline and corroborate or refute witness statements. It transforms a seemingly simple biological process into a powerful tool for justice. In conclusion, the stiffness that develops a body after death is not just a mysterious event but a scientifically explained consequence of cellular energy depletion. Rigor mortis is a temporary yet profound testament to the biochemical processes that govern life and death. From the initial locking of the muscle proteins to their eventual breakdown, this natural phenomena offers a fascinating glimpse into the body's final journey and provides invaluable clues for understanding the circumstances of death. For more videos, do not forget to like and subscribe our channel Zoosphere.